Okay, welcome to this class, and we are here to review the past question on JAMB or UTME. Alright, we have number one question. It said the surface temperature of a swimming pool on a one day is 25 degrees Celsius and the temperature at the bottom is 15 degrees Celsius. If the swimming pool has a surface area of 620 meters squared and a depth of 15 meters, find the rate at which energy is transferring or transferred by conduction from the surface of the bottom of the swimming pool. Alright, this question came from conductivity. As you can see, conductivity of the water was given as 0.6071 watt per meter per Kelvin. Alright, this question I will start with, okay? Alright, I'm going to have it Q over T is equal to K, A change in temperature all over L. Alright, from this question, remember Q is the quantity of heat, while the T is the time, but the quantity of heat over time is same thing as power, and that is why we have watt there. Alright, whereby this K is given as 0.6701. 0.6071, and then the temperature change. Okay, temperature change is going to be from 25 to 15, and that is going to be 10. So change in temperature is going to be 15 minus 10, and which is going to be 25 minus 10, which is going to be 15 degrees. So now this is actually 15, so this is 10 degrees Celsius. And then the area is 620, so A is given as 620 meters squared. So what is L? So what is our L? Our L is given there as 1.5. Okay, that is 1.5. So 1.5 meters. Alright, having put all these things, we just put them because I'm looking for Q over T. Q over T, that is a statement where they say find the rate at which energy is transferred. So when we talk about rate, we are talking about something being divided, time function, something which is considered by its time. So that is Q over T. In that case, and also our questions are given in watt, W, that is why we know that everything is going to be Q over T is given as K is something as 0.6071 times area is 620 times change in temperature is 10 all over 1.5. So you can just use your calculator. This is going to be I'm going to say 0.6071 times 6200 all over 1.5, which is equal to Q over T. And a careful study of this is going to be giving you, you just apply them. So I have 0.6071 times 6200 divided by 1.5. So everything I'm having here is 2509.34 in watts, right? But we are seeing K there. K means you are taking away, you are removing 1,000. So in this case, this is going to be Q over T is equal to 2.5 K watts. So because 1,000, 1, 2, 3, and that is what the point is. So because I'm dividing this by 1,000, I have this to 1 decimal place of a K. Alright, in number 2, we say the terminal of a battery of EMF 24.0 volts and the internal resistance of 1 is connected to an external resistor of 5 ohms. Find the terminal PD. Alright, in this question, we are talking about the electromotive force, which is given as capital V plus small v. Of course, you know this is very big where capital V is given as IR, and small v is called lost voltage. Lost voltage, which is I and small r. Please, the R is the same. So we say that E is equal to V, sorry, I'm not putting that, I'm saying IR plus I small r is equal to I all over R plus small r. Now, from this, since I am looking for PD, alright, so what I'm going to do is, first, let me get my current, because I don't know current. So I'm going to have 24 is equal to current is given R, capital R, which is the external resistor, is given as 5 ohms. Then the small r, which is the internal resistor, is given as 1 ohm. Alright, so this is going to be 5 plus 1. So I is going to be 24 all over 6, which is 4 ampere. So if the current is 4 ampere, then what is my PD? PD is just, terminal PD is something as this capital V, and the capital V is given as I multiplied by the capital R. So that PD, or terminal PD, is given as I is for 4, multiplied by the R, which is 5, and this is going to be 20 volts. 20 volts is there, okay? That is option C. But I think we didn't pick option 1. Option 1 was given as 2.5K, and let's go to number 3. Alright, in this number 3, he said a 400 Newton box is being pushed across a level floor at a constant speed by a force of P of 100 Newton. So that force, so what I'm going to do is, this is a horizontal, and this is P, and this P is given as 100 Newton. And it's pushing this body which is 400 Newton, and at an angle 30. Alright, so what happened? To the horizontal, of course, the body is moving on a horizontal level. That is fine, as shown in the diagram below. What is the coefficient of kinetic friction between the box and the floor? Kinetic friction, coefficient of kinetic friction. So, friction, when we talk about frictional force, is given as mu, which is coefficient of friction, multiplied by normal reaction. Okay? So, but in this case, the body is being pushed. So, two things are going to happen, because according to second law of motion, the body is moving in this direction. Then the opposite one is going to be the frictional force. So what you are going to do is force in this direction and then force in this direction. They are going to subtract. That is going to be the net force, because everything we do on motion is all about this. Summation of force of this x must be equal to 0. It is going to be equal to 0 if the body is moving with a constant speed. And was that shown here? We need to be sure, yes, the body is moving with a constant speed. So I am going to use this principle. However, if the body was moving with an acceleration, I'm going to say this is going to be equal to ma. Now the question is, what is summation of fx? When we talk about the fx, we're talking about the resultant force on the horizontal direction. And the resultant force must be equal to 0. So that means the force in the direction the body is moving minus the force opposing its motion. So in this case, we have a force moving in opposite. We are going to resolve this actually. We resolve it to the horizontal. Resolving this to the horizontal means I'm going to do this projection, and this is going to be Fy. This is going to be, I don't need Fy because the body is not moving in the vertical direction. The body is actually moving in this horizontal direction. So I have nothing to do with the F of the vertical direction. Now, I don't need Fy, I need Fx, which is the horizontal component of this force. So what is it going to be? I'm going to say that this is going to be Fx is going to be 100 cos 30. And this is the force on the horizontal direction. And this is the force moving this body in this horizontal direction, but there is a frictional force pulling it backward. So that frictional force pulling it backward is this Fr, which is equal to mu times R. This R is given as mg because it's the normal reaction. So I'm going to put mg here. So what should I do? This is going to be equal to 100 cos 30 degree minus mu mg is equal to 0. Now, this is what I'm saying. That is what I told you. Fx is equal to 0. So this is the net force on the horizontal component, and they must be equal to 0. So 100 cos 30. What is cos 30? Sin 30 is 0.5. So cos 30 is going to be 0.8660. So this is going to be 100 times 0.8660 minus, this is the coefficient of friction. I don't know it, so this is going to be mu times mg, which is 400, is equal to 0. So this times this is going to be 2 zeros, 1, 2. This is going to be 86.6 is equal to 400 mu. So this mu is going to be 86.6 all over 400, which is equal to, you just use your calculator on your system, 86.6 divided by 400. So the answer is 0.2165. Please, it does not have any unit. It does not have any limit. So because of that, we are choosing our answer, and our answer is D, because to the nearest two decimal places, 6 is rounded off, so it becomes 0. That. All right, we are moving to the next one. All right, the next question: a lorry accelerates uniformly on a straight line with acceleration of 4 meters per second and covers a distance of 250 in a time interval of 10 seconds. How far will it travel in the next 10 seconds? Okay, in this question, we are going to use this. Okay, we are using this plus half at squared because this is a question on linear motion. So on this case, I have acceleration, which is A, is given as 4 meters per second squared. I have a distance, S, is already there, 250. S is 250 meters. Then 10 seconds, time is 10 seconds, T is 10 seconds. Alright, so I don't know where the body started. I can still analyze this question using a graph. I can say that, look at it here. This is, I think, velocity time graph in seconds, meters per second. The body started moving because I don't know what this U is. They did not tell me the body started from rest. The body did not start from rest. So I do not know exactly what this U is. But what happens after 10 seconds? Then there is a given final velocity, which I still do not know. And what happened? He said the body continued. So that is what they say. The next 10 seconds, this place is going to be 20. There is a next 10 seconds. So if you check very well, this is a trapezium and this is a rectangle. However, this formula can deal with whatever I'm going to have here. At least let me know my U. Alright, so what I'm going to do now is this. I'm going to have 250, putting this inside this equation. I do not know U, I know T, plus half times, acceleration is 4 times, T is 10 squared. Alright, this is 250 is equal to 10U plus, this is 2 times 100. This is going to be 250 is equal to 10U plus 200. Alright, this is going to be, this coming here is subtraction. This is going to be 50 is equal to 10U. So U becomes 5 meters per second. Alright, I have found my U. So this U is given as 5 meters per second. Alright, so what happens? I have to, as I have found this U for this body, I want to find the distance next 10. That means from here, from this point to this point. But the distance from here to here, the whole of this distance is given as 250 meters. Remember, distance of this kind of question is area under the graph. So area under the graph, the whole of this trapezium is 250 meters. So we want to find the distance covered from here to here. And the best thing to do is as well use this formula and then do your subtraction. So the next 10 seconds, I'm going to say that S is equal to, U is given as 5. I'm still using this formula. I've found U to be 5 times next 10. So from here to here is also 10 plus half times A, acceleration is still, of course, from here to here is still 4 times T is going to be, because I'm talking about from here all the way to this place, then this is going to be 20 squared. Alright, so in this case, no, this is going to be 20. So this is going to be, S is going to be 5 times this is going to be 100. Then plus, this is 2 times, this is 400. So S is going to be 100 plus 800, which is 900. Now look up. At this point, from here to this place is what? 900 meters. That is, from here to this is 900, area under the curve. However, I'm looking for the next 10 seconds. That means I'm looking for from here to this place. So I'm going to minus 20. Minus 250. So 900 minus 250. 0. This is 5. What's remaining here is 8. And this is 6. 650 meters. And 650 meters, do we have it? Is option D. We go to the next one. Alright. And this is number 5. In this number 5, a battery of EMF, you saw something like that. EMF is 12 volts, 12.0 volts, and the internal resistance of 1 ohm. So small r is 1 ohm. Is connected to an external resistor. R, external must be big one, and that is 3 ohms. Find the power delivered to the battery. Alright, when we talk about power delivered, you see, every battery is a machine. Every battery is a machine. Is a machine. And because of that, it has 2 things. It has internal, it has output work and input work. So the work we are talking about must be in and out. In that case, first of all, let's find the current. Because without current, you can't find power, because power is given as IV. That is the power, IV. But in this case, I don't know I. So let me get I before I start using this formula to find the power. So according to what we did before, this is the formula. E is 12, I unknown, R is 3 plus 1, I is 12 all over 4, which is 3 ampere. 3 ampere. Now, output work, output power. Output power is given as P is equal to I is 3 times out, external resistor is 3. Oh, sorry, I'm not using this V. There is a formula for power also, which is given as I square R. This is what I'm looking for, not this. So I'll say P is equal to I is 3 square times capital R, which is 3, which is 9 times 3, which is 27 watts. This is the output power. Another power is the input power, which is given as I the I there is 3 times the 3 square times the small r. Small r is this one, which is 1, which is 9. So total power is output plus input. So this is going to be 27 plus 9, which is going to be this is 36 watts. That is the power delivered. And that is option D. Alright, I'm going to claim this both side for this question. Take resolution of forces. 3 forces with magnitude 16, 12, and 21 as shown in the diagram below determine the magnitude of their resultant force and angle with the x-axis. Alright, I am going to resolve this force. How do I resolve it? Each force must be resolved to both vertical and horizontal components. So I'm going to just use this principle. I just want to do it this way. And this one is 12 Newton and at an angle of 32 degrees. And this is right somehow because JAMB does not really have scientific calculator in their system. So let me use this one to find out. So we do not have that angle 32. However, we also have this one 16, and that is under 26 degree 16, and this is already given as 21. So see what I will use. I'm going to use this platform. This is F, everything here is Y, everything here is X. So I'm going to resolve this to the vertical and to the horizontal. I'm also going to resolve this to the vertical and to the horizontal. This is already here. It is already given as a vertical component, 21 Newton. So, 32, I'm going to call anything on the vertical Fy, anything on the horizontal Fx. The same thing, Fx, Fy. So let's go. This is going to be adjacent over hypotenuse. Adjacent over hypotenuse is cos. So Fx is what? 12 cos 32. So Fx is what now? Twelve cos 32 is 10.2 or 10.1. Yes, 10.2. So this is 10.2 Newton. And since it is here on this side, I'm putting this 10.2 Newton. So it is left for them because these things are not special angle. Normally the question shouldn't come with them. Okay, so the next one I'm going to resolve this same one to the vertical. It's going to be opposite over hypotenuse. Opposite over the hypotenuse, which is sine. So sine, this is Fy, which is the vertical component of this force, is going to be 12 sine 32. Maybe, sine 30 is 0.5 and cos 30 is 0.8660. So with that, you may have a question which is close to it. Let's assume this is sine 30. So this answer is going to be 6 times 0.5 is going to be 3. However, we are going to have a number which is very close to it, which is 6 point, maybe 1 or 2. So let's find out. If I have 12 sine 32, 6.4 approximately, 6.4. So this is going to be 6.4 Newton. Alright, so 6.4, the same thing we are going to do here. Adjacent to hypotenuse, cos Fx is going to be 16 cos 26, 16 cos 26, 14.4. So this is going to be 14.4. 14.4 on this direction, and another one, Fy is going to be 16 sine 26. 16 times 26. 16 sine 26, which is 7.1 7.0. So this is going to be plus 7.0. Alright, so I've resolved this horizontal, I've resolved this vertical. I've resolved this horizontal, I've resolved this vertical. Now we have this. What does that simply mean? It means that this and this, so these two added together is going to be this plus this is 13. 13.4. And this minus this, okay, this is 14. 14.4 minus 10.2, this is 2 point, this is 4.2. Alright, what it simply means is this. The force, this particular one, okay, we also do that subtraction. We have, this is going to be Fy. Well, this minus is so 21.0 minus 13.4. This is 10, which is 6, which is 20. 20 minus 13 is 7, 7.6. So I'm going to have this. It's also positive. So since they are all positive, okay. No, this one is moving in this direction. So this is going to be 7.6, and this is 4.2 Newton. Now, according to parallelogram law of vectors, I'm going to do this. This is going to be the resultant. And Pythagoras theorem, of course. So this is the theta we are looking for. Now let's go. In this case, the resultant R is going to be 7.6 squared plus 4.2 squared. And R is going to be 7.6 squared. You can also use this. So 7.6 times 7.6. We have 57.76. 57.76 plus 4.2. 4.2 times 4.2. 17.64. 17.64. So R is equal to, you add them, 57.76 plus 17.64, 75.4. 75.4. So R is square root of that. So this is square root of 75.4. We have 8.6. Okay, we have 8.68. So everything is going to be 8.68 Newton. Now for this one, tan theta, this is going to be opposite over adjacent. So angle tan theta is going to be opposite, which is 7.6 all over, which is 4.2. So 7.6 divided by 4.2, which is 1.81. Tan inverse, theta is going to be tan inverse of 1.81, which is going to be 61 degrees. Therefore, the option we have here is 8.6. This is R is approximately 8.7 Newton and 61. We have 8.7. Okay, that is A, option A. 8.7 Newton and 61. All right. So we are going to the next. Honestly, this question is to worry students in the whole. Okay. Now, number 7, a wire of radius 0.2 millimeter is extended by 0.5% of its length when supported by a load of 15 kilogram. That is 1.5 kilogram. Determine the Young modulus of the material of the wire. Alright, when we talk about Young modulus is equal to stress all over strain, and stress is F over area divided by stress is extension all over length. So Young modulus is given as F over A times L over E. Okay, so this is going to be equal to FL all over AE. Now, from this question, A, because it's a wire, remember, any wire you see, if I zoom it, I am zooming this wire right now. You know, wire is very small, according to what you think. But if you zoom it very well, wire is like a cylinder with a circular face. Because of that, the area is a circle. So we're going to say A is going to be equal to pi r squared. So this equation is going to be Young modulus is given as FL all over pi r squared times E. Now, the mass is given and the force. Force is going to be mass times G. Of course, like the weight, which is 1.5 times 10, which is 15. So the F is 15 Newton. The length, I do not know the length. The pi is 3.142. Then the R is given in millimeter, we have to convert it to meter. So that is simply by dividing by 1000. So I'm going to say 0.2 millimeter, if I divide it by 1000, and this is going to be 0.0002. Is it correct? This one goes 2 zeros. Yes, 3 zeros in meter. So this is the radius in meter. But remember, the radius here is squared. Alright, so I'm going to do everything at the same time. But then the extension, they say that the extension is extended by 0.5% of the length. Okay? Extension is 0.5% times the length. Extension is going to be 0.05, because 0.5 divided by 100 is 0.005. I think so. Yes, 0.005. If I multiply this by 100, yes, 0.0L. So we are going to put them all into this equation or relation. Then we say that Young modulus is F is 15 times L, I do not know the length, all over. Pi is 3.14 times R is 0.0002 all squared times E 0.005 L. L, we cancel L, right? Squaring this, okay, let's just use our calculator to reduce the time. Okay, this is going to be 3.142 times 0.0002 squared times 0.005. Alright, this is going to be 15 times 10 raised to the power 0 all over 6.28 times 10 raised to the power minus 10. Alright, you know why I said times 10 raised to the power 0? I just want to express these two as a standard form. Let me express this one as ordinary number. So this is dividing the 15 divided by 6.28, and this is 2.38 or 2.39. Then times 10 raised to the power. This time is going up to become 10. Alright, this is Young modulus is given as 2.4 times 10 raised to the power 10. Young modulus, the unit is given the Newton meter square per meter square. 2.4 times 10. 2.4 times 10. Alright, 2.4 is here. Alright, number 8. A ball thrown vertically upward with an initial velocity of 50. What is the velocity of the ball on striking the ground? Okay, so this is a question on motion under gravity. So if I have u as 50 meters per second, that is the speed with which the body was thrown up. Then we are going to have a final velocity with which the body is going to be 0. Vy at this point is going to be 0. So u is, so the body is moving this way and it falls down. So we are looking for the v at this point. So from here to this place, this one is 0 and g is 10. So I'm using vy is equal to uy minus gt. This is 0. This is 50 minus g is 10 t. So t is going to be, so this is going to be 10t is going to be 50. T is going to be 5 seconds. The time it takes to go from here to this place is 5 seconds. And the time it takes to go from here back to the ground is going to be also 5 seconds. So the total time from here all the way to this place is going to be t is going to be 2 times 5, which is 10 seconds. Now the question is, what is the velocity with which it strikes the ground? So if I call this one 0, yes, it's going to be Vy is going to be equal to U y plus gt. Alright. This final velocity I'm looking for, because it's plus, this is going to be Vy is going to be, alright, actually, so if I'm looking for from here to here right now, so if from here to here is 5, then this is 0, which is the initial velocity is 0. So this is going to be 0. Because this one now is initial, because I'm moving this way. This is the final. Yes. Therefore, plus g is 10 times, from here to here is 5. So Vy is 50 meters per second. So we are going to the next one. I have 50 here. Okay, a rainbow formation is as a result of the combination of which of the following phenomena? Reflection is not an issue of rainbow. Okay, reflection is not there. Dispersion, of course, different colors has to dispatch. Have to separate between one color and the other. So dispersion is part of it. Total internal reflection, yes, because when light is passing from one medium to the other, there must be a reflection and a refraction. So that one should be a total internal reflection. So the answer is going to be 2, 3, 4. 2, 3, 4 only. So B. A parallel plate capacitor with a parallel plate capacitor separated by an air gap is made of 0.8 meter square thin plates and 20 millimeter apart. If the connection to 120 volt battery, what is the charge on the plate? Alright, so we are going into capacitor. So a capacitor is, normally this is quantity of charge is given as C times V. So this is the voltage, this is the quantity of charge, and this is the C, which is the capacitance. But this capacitance can also be given as this permittivity of a free space multiplied by area divided by D. So I need C before I can find Q, because I have to substitute this value into this. So if I can do all of them at the same time, I have permittivity multiplied by area multiplied by D times V. V in this case is given as 120. So E naught, which is given as 8 point. Okay, so I'm substituting straight. So I have 8.85 times 10 raised to power minus 12 times area A. A is given as 0.8 times V is 120 all over D. D must be converted to meter, so we have 20 millimeter. So to convert 20 millimeter to meter, I have to divide by 1000. So I have 0.002 or no 0.02. So in this case, this is going to be 0.02. So what do? We go into multiplication. All right. In this case, let me convert all this to indices, I have 8.85 times 10 raised to the power minus 12 times 8 times 10 raised to the power minus 1 times 1.2 times 10 raised to the power 2 all over 2 times 10 raised to the power minus 2. Alright, so 8.85 times 8 times 1.2 divided by 2. So I'm going to have 8.885 times 8 times 1.2 then this is divided by 2. I have 42.48. So this is going to be 42.48 times 10. Now let's work with all the powers of 10. This is 2, and 2 minus 1 is 1. 12, this is going to be minus 11, and plus 2. This is 2.4248 times 10 raised to the power minus 9. Alright, which is 4.248 times 10 raised to the power 1 times 10 raised to the power minus 9. So what do we have then? Okay, 42, I have 42 points, yes. So there's no need of me going in here. Because there is n, you have seen that n is a prefix, which is 10 raised to the power minus 9. So I'm going to remove this and put n, this is 42.5 none. And colon, because charge is there. So that is the answer. G. We're going to the next question. Alright. Now the next question is saying that this is a moment of force. He said that a 200 kilogram load is raised using a 110 meter long lever as shown in the diagram above. The load is 10 meters from the pivot. If the efficiency of the lever is 80%, find the effort required to lift the load. So I also know that efficiency is work output all over work input times 100 over 1. So in this case, work output is going to be what happened to the load. So work is force times distance, okay, which is going to be 2,000. Now, the work there is going to be force times distance it has moved. The force there is going to be 2,000 because 200 times 10 is 2,000 times the distance it has moved. 10, which is going to be 1, 2, 3, 4 joules. So that is the work output. Alright, the work input is going to be what the effort has done, and that is going to be E work input, which is going to be E times 100. So where is the 100 from? Where E is to the point of pivot, which is going to be 100 E. So I'll go back. Efficiency is still 80, which is equal to work output is 2,000, is 20,000. All about velocity ratio, this part, which is the work input, is going to be 100, this times 100 over 1. So I'll have this, we cancel this. Then this is cancelling this. So this is 8E is equal to 2,000. And E is equal to 2,000 divided by 8. And this is going to be 250 Newton. Alright, the option there is 250 because 2,000 divided by 8 is 250, and that is option B. Alright, so we're going to the next one. Number 12. Number 12, a man swung an object of mass 2 kg in a circular path. So in a circular path, a man swung an object. So for an object to move in a circular path, it must have a force pushing it in a circular path, and that force is centripetal force. So the tension in the rope if the object was swung at 120 rev per minute, find the tension in the loop. The tension in the loop must be provided by centripetal force. Centripetal force is given as mv square over r. Now, there is a frequency there because we have to find that to be frequency because number of revolution per minute. Now, we are going to say that frequency is equal to 120 revolution divided by 60. If I can, minutes. If I can convert this thing in seconds, then I have found this frequency. Because frequency means the number of revolutions per second. So I'm going to convert this minute to seconds. So that is going to be 120 rev all over 60 seconds, which is going to be 12 revolutions. Now that is for the frequency. But remember that V is instantaneous velocity, which is moving as the body is rotating in a circular path. So that V is given as R omega. So V inside here is going to be Fc is going to be M. This V is R omega all squared divided by R. This is M omega square multiplied by this angular velocity divided by R. This cancels this. I have that. Okay, so this is also squared. I have the centripetal force is mr omega squared. All right. Now the question is, what is this angular frequency and angular velocity? Given as 2 pi f. This is given as 2 pi. F is 2, which is going to be 4 pi. Now, centripetal force, which I'm looking for, which is the tensional force, is going to be M is 2 times R is 1.2 times. This is going to be 4 squared, 4 pi all squared. And Fc is going to be, this is going to be 2 times 12 is 24, which is 2.4 times 16 pi squared. Everything is going to be, if you use your calculator very well, it's going to be 2.4 times 16 times, okay, this is 3.142 in place, 2 places, 3.142 times 3.142, which is 379 approximately. The answer is C. So let's go to number 13. A wave traveling at this, a traveling wave of amplitude 0.8 meter has a frequency of 16 Hz and a wave speed of 20. Calculate the wave number. Alright, when we talk about wave number, we have K, which is 2 pi all over lambda, is given as wave number. If it is phase angle, it's going to be 2 pi x all over lambda. So there are two different things. Now, the amplitude is given, and speed of the wave is also given. So the amplitude is there. Okay, so what I'm going to do, I have this f lambda. Since they have given me the frequency, so V is equal to frequency 16 times, I don't know the lambda, so I'll call the lambda. V is given there as the speed of the wave, which is 20. So lambda is going to be 20 all over 16, which is 4 into this is going to be 5, 4 into this is 4 in meters. So I'll solve that here. The wave number is going to be K is equal to 2 pi divided by 5 over 4. So K is going to be 2 pi times 4 over 5, which is, this is 8 pi over 5. So the 8 pi, which is going to be 8 times 3.142 divided by 5, which is 5.0, so approximately 5. The answer there is D. So when a sound wave passes from air into water, when a sound wave passes from air into water, the A, speed and wavelength decrease, but frequency remains the same. B, speed and frequency increase, but its wavelength remains the same. Speed remains the same, but wavelength and frequency increase. Speed and wavelength increase, but its frequency remains the same. Alright, before we answer this question, I want you to know what happens, and according to Lenz's law. Snell's law. Snell's law says that the refractive index of a medium, as light passes from one medium to the other, he said that V of A is going to be different from V of B. So the velocity or the speed changes between one medium and another. So velocity must change. He also made mention of the wavelength. The wavelength of A and that of B, they all give the refractive index of the medium. So the speed and the wavelength must change. There was nothing like that for a frequency. So in that case, frequency must be the same. The speed and wavelength must change. So the option is A. In option B, the speed and frequency increase. So provided frequency has changed is wrong. So any of the places where frequency increased or decreased means that they have changed, and in that case, it is not the right option. So that is that. Now, a railroad track made of steel has a length of 55 meters when the temperature is 0 degrees Celsius. What is the length on a hot day when the temperature is 40 degrees Celsius? So, this question should be under linear expansion. According to linear expansion, L2 minus L1 all over L1 times change in temperature. So this is linear expansion, and in that case, we are given linear expansion of 1.1, so this is 1.1 times 10 raised to the power minus 5, minus 3. L2, we are not given L2. So what is its length when they hold this? So the increase in temperature has to do with the second length. It was not given. Minus L1 is going to be the original length of the rail, which is 55, all over 55 times. Change in temperature is going to be 40 minus 0, which is 40. Alright, we are opening this. So 55 times 40, 220. So this is 1.1 times 10 raised to the power minus 3 is equal to L2 minus 55 all over 2200. Alright, so, and I'm going to say L2 minus 55 is equal to 1.1 times 10 raised to the power minus 3 times 2.2 times 10 raised to the power 123. Alright, so L2 is equal to 55 plus, 55 is going in to be plus 1.1 times 2.2, so 1122, which is going to be, but then this 10 raised to the power 3 and this 10 raised to the power 3 are cancelling, so 242, we have 242 times 10 raised to the power 0, so everything here goes out. 242, this is 1 and 2 points. 2.2 times 10 raised to the power 3. This is 10 raised to the power. Is that minus 3? Minus 5. Oh, minus 5. So this is minus 5. Alright, so this is going to be times 10 raised to the power minus 5 and 3. 3 minus 5 is minus 2, which is L2 is going to be 5 plus 0.0242. Alright, so L2 is going to be 55.0242 meters. 55.042, and that is option A. And which of the following is not a postulate of molecular kinetic theory? According to molecular kinetic theory, he stated, okay, the option there is the collision of the gas molecules are perfectly elastic. Alright? The collision of the gas molecules are perfectly inelastic. That's option B. Option C, Option C said the average kinetic energy of the gas varies with temperature. And then option D, the volume of the gas molecule. So on this, if you consider the postulate according to molecular, now there are two major things which to me I am considering where the answer lies, because the average kinetic energy of a gas varies with temperature. Of course, temperature is based on the average kinetic energy of the gas. That's temperature. That's the definition of temperature. Now, the volume of the gas is negligible compared to the container. Yes, it's negligible. Then, because the other one now said the collision of the gas molecule are perfectly inelastic. Is it true? What is inelastic? And the other one said the collision of gas are perfectly elastic. So the option there is not. Okay, when it is not, the option must be B, because for here, according to kinetic theory of gas, they are perfectly elastic. That means they keep colliding with the walls of the container, so it must be inelastic. It's not one of the theories. So going to the next one, number 17. The simple pendulum has a period of 5.77 when the pendulum length is shortened. When the pendulum is shortened by 3 meters, the period is 4.60 seconds. Calculate the length of the pendulum. Alright. This question came from a principle that the square of the period is directly proportional to the length. So that simply means that T square is equal to KL, whereby K is T square divided by L. Now, this is a constant. For it to be constant means T1 all over L1 must be equal to T2 square all over L2. But it happens that L1 from this question, L1 is given as L. We do not know the original length. But the L2 was shortened by 3. So the length was reduced by 3. So the original length, which I do not know, L, was reduced by 3. We remove 3 from it. Now, the T1 is given as 5.77 seconds. And T2 is given as 4.60 seconds. So we're going to use all this, plug them into this equation to see if we can get maybe 6.42 or 5.23. Okay, let's start by putting them there. We have T1 is 5.77 all squared all over L. L1 is something as L, which is equal to 4.60 square all over L minus 3. So this is going to be 5.77, that is 5.7 squared. You just use our calculator, you can use the one on that board. Okay. You can also just say 5.77 squared. So we have this multiplied by this, which is 33.29, then multiplied by L will be this, minus this one multiplied by 3, we have 99.88. 99.88. So this is going to be equal to this multiplied by this, 4.6 squared. 4.6 squared is going to be 21.16 L. So this time the first one is this time the second one is this. So we have this minus this. This is going to be 9 minus 6 is going to be 3. 2 minus 1 is going to be 1. 3 minus 1 is 2. And 3 minus 2 is 1. This is equal to 99.88. Carry 9 to this side, it becomes plus. Carry this from this side, it becomes minus. It's subtracted. So L is going to be 99.88 divided by 2, 12.13. I'm sure that is it. And when we do that, what do we have? We have 99.88 divided by 12.13. So L is equal to 8.23 meters. Alright, so do we see that option there? Okay, the option is not there. But what? Okay, calculate the new length. This is actually the new length. This is the new length. Therefore, I'm going to say L minus 3, which is something as 8.23 minus 3. So this is 8 minus 3 is 5.23 meters. And that is in option A. Okay, number 18. Okay, this number 18, if you look at this question, we have FT graph. FT graph, the area under the curve must be a momentum. So this is going to be momentum, which is M, which is going to be MV equal to FT. But this is actually M bracket V minus U equal to FT. Because this is change in momentum is equal to the impulse. The impulse is F times T. So what I'm going to do first is going to find the FT. The FT is area under the curve, and the area under the curve is the use of trapezium, because that's the trapezium, the shape. So what I'm going to do is FT is going to be equal to half bracket A plus B times height. So impulse or FT is going to be, what is my A? A is going to be from 5 to 3. That means 5 minus 3 is A, which is 5 minus 3 is 2 plus from 0 to 8, which is 8 here, which is for B, times height is going to be 5, because 0 to 5 is the height. So this is going to be FT is equal to 1 over 2 bracket 10 multiplied by 5. This one, this is 5. 5 times 5 is 25 Newton seconds. So this is the area under the curve according to this question. This area under the curve is momentum, which is mvu minus v minus u. Now the question said find the final velocity of the particle if it is initially at rest. At rest, u is equal to 0. So that is going to be mv minus mu is equal to 25. So m is the same thing there as 5 kg. So this is 5 bracket. V minus 0 is equal to 25. Therefore 5v is equal to 25. V is 5 meters per second. 5 meters per second, that is V. Now another one said, and when it is at V minus 4. So I'm going to go to this U, put minus 4 there. When I put minus 4 there, I will have M bracket V minus U is equal to 25. So this is 5 bracket V minus 4 is equal to 25. So this is 5 bracket V plus 4 is equal to 25. Divide by 5. V plus 4 is equal to 5. So V is equal to 1 meters per second. So there are first one 5, second one is 1. So we are of which of these options? 5 and 1, correct. So we are going to the next one. Okay, this one is under heat. So what is the amount of heat required to raise the temperature of a 0.02 kg of ice cube from minus 10 degrees Celsius to 10 degrees Celsius? Specific latent heat of fusion of ice is 3.3 times 10 raised to 5 joules per kilogram, and specific heat capacity of water is 4,200 joule per Kelvin per kilogram. Specific heat capacity of ice is 202,100 joules per kilogram per Kelvin. So we are going to find the amount of heat needed to cause a change in temperature from. Alright, for me to do this, I usually like, for my explanation for students to understand it better, I like to use this. This is minus 10 and this is 10 degrees Celsius, Now at this point, two things will happen, and I'm using different colors to show you what is happening. So at this point, this is 0, which is this change of phase, because I am sure we are talking about water. Yes, ice. From there, we get to water. So when ice goes from any lower temperature, when it reaches 0, because this place is 0, what happens? A change of phase will start happening. There will be a change of phase, and that change of phase will make that change of phase will not allow this to continue going up. It will never go up. It will lag then before it takes up. Therefore, I'm going to show you different stages. So there is a stage A to B, and there is B to C, and then whatever it takes for it to reach this level at 10 accordingly. So the amount of heat required to have for this to happen means that it will go from A to B. So I'm going to say quantity of heat from A to B plus quantity of heat from B to C plus quantity of heat from C to D. That's my explanation for you. Then quantity of heat from A to B is what? Whenever you see a straight line like this, it is MC change in theta for the ice. This one is for ice. Plus, when it comes to this point, this is a change of heat, change of state. Whenever we have a change of state, there are two kinds of change of state. It's either fusion or evaporization. So it's fusion because it's changing from solid to liquid. So you have MLF, then plus. So the next one is from here to here, which is also MC change in theta. This is for water. All right. So we are going to keep putting in their values according to what they are. So for this mass of the ice is given, for this one, mass of the ice is 0.02 times specific heat capacity of the ice is going to be 2100 times. Change in temperature from here to here is just 10 because 0 minus 10 is just going to be 10 plus. So plus, the next one is going to be, this one is also going to be 0.02 times specific latent heat of fusion. Specific latent heat of fusion, which is 334. This is 334,123. Raised to power 5. Then plus M for water, mass of water. I'm still going to use because this mass did not change, which is 0.02 times. Specific heat capacity of water is 4200 times. Change in temperature from here to here is going to be 10. So add everything here, you have the answer. This is going to be 2 over 2 zeros, 100 times 2100 times 10. 2 zeros, we cancel 2 zeros. This is 2 times 1 times this. So this is 42 times the, which is 420 plus. Coming to this one, this is 2 over 100 times 334000. 2 zeros, cancel 2 zeros. So this is 2 times 4 is 8, 2 times 3 is 6 plus. This is still going to be 2 over 100 times 4200 times 10. 2 zeros cancel this 2 zeros. This is this times is going to be 84. This is 0, of course. So if you add all of them, you have 420 plus 668. Sorry, this is 4 here. I started here, but something that is 0 in here. 6680 plus 840. 7940. 7940 is the total quantity of heat for this to happen. And the option there is number option A. Alright, I'm going to the next question and number 20. Wow, we're praying for a theory question or many calculations. So we are going out, this one is out. The distance between two parallel horizontal wires. Okay? parallel horizontal wires carrying the same current in opposite direction is 20 cm. If the force between the wires per unit length is 10 raised to the power minus 4 Newton per meter, calculate the current carried by the wire. Calculate the current carried by the wire. Is the force between the wires attractive or repulsive? Okay, we are going to answer this question. But before that, we know that the force, electrical force, for a wire carrying conductor is given as BIL, sometimes sin theta, depending, whereby this B is the field I. Okay. Alright, so I am going to put it this way. If I have, this is going to be F all over L is equal to BI. Alright, whereby, like I said, B, that is the field which is, of course, all over 2 pi R. Yes, that is it. So this is F over L is equal to U naught, which is the constant given there, multiplied by the current for the first one, and because this one is a different current and this is a different current, and let me call this one L1. So all over 2 pi R, and this is I2. So this is the formula that will help us do this. But the distance between them is 20 cm, which I'm going to convert to meter. But the question has given us F over L, which is 10 raised to the power minus 4. So everything here is going to be as 10 raised to the power minus 4, which is equal to U naught is already given to me as 4 pi times 10 raised to the power minus 7. Then times. Now there is a statement they made that they say that the same current flowing. The same current means that means I1 must be equal to I2, and that is equal to I. So that is I squared. Then all over 2 pi times R. R is 20 cm. I must convert it to meter by dividing it by 100, so it becomes 0.2. Now 0.2, 0.3 is centered as 2 times 10 raised to the power minus 1. So I'll go with 2 times 10 raised to the power minus 1. Alright. So I am looking for this current. The best thing I need to do is to cancel out this pi, we cancel this pi. Alright. 2 and 2 will cancel 4. Alright. Okay? So I will have now 10 raised to the power minus 4 is equal to 10 raised to the power minus 7 I squared. Sorry. This is minus 1. And this is I2. So this is 10 raised to the power minus 4, which is equal to 10 raised to the power minus 6 I squared. So dividing both sides, so this is going to be I squared is equal to 10 raised to the power minus 4 divided by 10 raised to the power minus 6. So I squared is going to be 10 raised to the power minus 4 plus 6. So I squared is going to be 10 raised to the power 2. And 2 cancels to I is equal to 10 ampere. So 10 ampere there. So the question now is that, is the force attractive or repulsive? It must be repulsive because they're moving in opposite direction. So this is going to be 10B.